Good morning, everybody. Grade 9. We are going today to start our session about Chapter 2, Chemistry. And Lesson 2 will be the mixtures. We said that mixture it's a blend of two things or more together physically, not chemically, because we get the difference between the physical and the chemical last session, as we said. So, for example, he's saying here, why aren't there coffee grounds in cup of coffee. So the coffee is often brewed by mixing hot water with ground coffee. You know, sometimes you get it like that. Describing the matter, how can mixtures be classified, guys? We can say, for example, we have salad, and the salad contains a lot of things: lettuce, tomato, cucumber, cheese, and green pepper, a lot of things together. Can you separate them? Yeah, you can separate them, and they are easy to be separate again into their components, so that's a mixture. So the mixture is a physical blend of two or more components. Let's move further, guys. Most samples of matter are mixtures. Some mixtures are easier to recognize than others. You can easily recognize chicken noodle soup as a mixture of chicken and noodles or broth, and the broth too. So, recognizing air, a mixture of gases, is more difficult, guys, like not like the noodles and the chicken, because you cannot differentiate between the water vapor inside, the oxygen, the nitrogen, all are colorless and odorless. So, based on the distribution of their components, mixtures can be classified as heterogeneous mixtures, as we see before in the noodles and in the salad, or homogeneous mixture like you see in the air. So heterogeneous mixtures in chicken noodle soup, the ingredients in the soup are not evenly distributed throughout the mixtures. So there is likely to be different amounts of chicken and noodles, so you can recognize that and you can differentiate between them easily. Yeah, and heterogeneous mixture is a mixture in which the composition of the elements of it is not uniform throughout it. So let's go to the other type, which is homogeneous mixture. So the substances in the olive oil are evenly distributed throughout the mixture. You cannot even differentiate between them. So olive oil does not look like a mixture itself inside. Let's go, guys, further for the same is true for vinegar. If you get to the vinegar is a mixture too of water and acetic acid, which dissolves in water too. So you cannot recognize or differentiate between the particles here even. So olive oil and vinegar are homogeneous mixture as the composition of each element is uniform throughout it. Okay, so all of the components are distributed in a uniform way that you cannot recognize how to differentiate between them. And in another term, we can call the homogeneous mixture as a solution. Okay, so many solutions are liquids, like you see before in the olive oil and the vinegar, but some are gases like air. It's a mixture or a solution. It will be gas solution, consists of a lot of gases, nitrogen, oxygen, and etc. And some are solids, like stainless steel, which a mixture of iron, chromium, and nickel. So the term phase is used to describe any part of a sample with a uniform composition and properties. By definition, a homogeneous mixture consists of a single phase. So you can see one phase for it, even it was gas phase for gas solution, or liquid phase for liquid solution, or even you will get the solid phase for the solid solution. The heterogeneous mixture consists of two or more phases, so you can differentiate between them. Like you see here between the oil and vinegar, you will get two different phases here, or two different separate layers. So, or let's get example to refresh our minds. At the beach, yeah, you realize that both ocean water and sand are mixtures, which is a homogeneous mixtures, or solution, which is a heterogeneous mixture. So let's see. When we get to the salt water itself of the ocean, it will be already homogeneous mixture because there is salt and water and they are in one phase, which is liquid. But when we get to the mixture between the ocean water and to the sand itself, the mixture can be differentiated because that's solid and that's a liquid. So that's, guys, a heterogeneous mixture. So our mixtures are separated. We are going to separate the mixtures into their own original composition or components inside. How come? It's accordingly to their properties, guys. So when we get the mixture between a solid and liquid, you can separate it through filtration. But when you get it according to that one of liquid and liquid, or sometimes solid and liquid, you can use distillation according to the boiling point of the liquids. Yeah. For example, here, if you have a salad containing ingredients you do not like, you can remove them, and that's easy. But when we get to the chemicals and the substance, that will be more complicated a little bit. So to separate the mixture of olive oil and vinegar, for example, you could decant or pour off the oil layer, or you might cool the mixture until the oil turns solid and you can separate it mechanically after that. Pouring off the oil layer, yeah, take advantage of the effect of oil float on the water. But cooling until the oil layer turns solid takes advantage or difference in temperature at which the olive oil and vinegar freeze. So if they have different types of freezing point, so it's easy to separate too. Yeah. So differences in physical properties can be used to separate the mixture also, as we said before. Yeah, for example, to filtrate the coffee, you know that the brewed coffee can be a solid part and also the water can be the other part, which is liquid. So filter paper can be used in the laboratory, is similar to the coffee filters too. Yeah, the filter paper is often placed in a funnel, and the funnel is a cone shape, as you will see after. Then the mixture is poured into the funnel, and the solid particles cannot pass because of the remains of it will stay on the filter paper, and the liquid will get down to the flask. Yeah. For the filtration, the process that separates the solid and the liquid components of heterogeneous mixture. Yeah, distillation, guys. Distillation, for example, tap water, yeah, is homogeneous mixture of water and substance that, as you see before, the minerals inside it that are dissolved in this water. Oh, one way to separate water from the other components in the tap water is through the process called distillation, guys. During distillation, the liquid is boiled to produce a vapor, then you will condense it again into itself liquid again. Yeah, that's the figure of the apparatus you use it to get the distillation. First, it will start by a flask, and the flask will be, heated by the Bunsen flame, and you have a holder here in order to be controlled and safe. And that thermometer will tell you at which point it will start to boil. And also we get a tube here, and the tube here is getting water from two from two ways in order to cool it and to cool this vapor again into the filtered or the distilled, sorry, water again. So, and that's a holder too. So the mechanism will start by heating first the tap water, and after that at 100 it will start to boil and evaporate, and it will get the vapor here through this tube, and the cold water inside here will start to cool this vapor in order to condensate, and the vapor will condensate into droplets here and get back to the flask. And the rest of the minerals or the undissolved one will stay here in the flask by the end. And that's type of distillation we get, guys. So to make it easy, guys, if you get other thing, if you got two liquids together, not solid and liquid dissolved, yeah. If you get two liquids together, you can use that also according to the difference in the boiling point between the two liquids. Yeah, let's go further, guys. Separating heterogeneous mixture like aluminum nails and iron nails to be separated. It's easy. You have to know some of the physical properties of the both elements. So if you get that, you will get that the iron, it's easy to stack to a magnet. So it's easy to use a magnet to differentiate between them. That's the concept we get together today, guys. Mixtures can be classified into heterogeneous and homogeneous based on the distribution of their components. And don't forget that the homogeneous is called also solution. Yeah. Differences in physical properties can be used to separate mixtures. Yeah, never forget some definitions about the mixture, heterogeneous mixture, homogeneous mixture, and solution. Yeah, never forget that if we got one phase, it will be homogeneous. If we got more than one phase, it will be heterogeneous. Yeah, filtration is used to differentiate or to separate two, yeah, two matters. One of them is solid and the other is liquid. And distillation can be used even to differentiate or separate solid and liquid or dissolving matter inside each other. Yeah, you can use that, guys, through your laboratory too. Hey guys, yeah, wait for my assignments and homeworks to personally realize, and don't forget to solve it. Thank you, guys.